Okie dokie, ladies and gentlemen, here we go. Wait, we got to get you on. There we go. We're here. Now we are live, ladies and gentlemen. Live. Yeah, we're live. Good. Okay. Live at East Jackson on September the 10th. Woo! September the 10th. Now, ladies and gentlemen, see, if I said write the explicit form, right? What do I need in order to write the explicit form? Just kind of curious. First term and what? Common difference, right? Hey, look at that. Yeah? So I'm just curious. Would you be able to decipher between this? What is the difference between these two? Okay, the bottom one is in terms of what? How do you know it's in terms of zero term? Just curious. Shh. There's what? Where's it at? Who said it? No minus one. No n minus what? Do you see an n minus one, guys? No. Did you know it's not the zero what? Term. Now, you can't. This is in terms of first term. Right here. If I want to go between first term and zero term, all I have to do is distribute, then combine like terms. I'm done. Okay? You never want to do this.
Well, where does 6 go?
That's funny you should say that. What's 5 times negative 1? What's 6 and negative 5? See, if you don't distribute those, then you're not going to get it. Do you understand? And those are things. So some people might, and look, that's. Let's just be honest. We probably got some people now sitting right now that didn't get this, right? Yay or nay? Yeah, didn't get the circled one. Raise your hand if you did not get that. Be honest with me. Okay, thank you. Appreciate that. All right, so, but here's the common mistake when people are looking at doing the zero term, okay, is they do this. That's wrong. Why is this wrong? You don't just put A1 and drop the n minus 1, guys. You just don't do that, okay? That's not zero term. It's not A1 and the common difference. That's not it. Because zero terms means it needs to be A sub 0, right? So that would be a big old what? No. Correct? Any questions? Anybody? All right, so I want to make sure just some things that you see and along the way and all this other stuff, right? Okay. So let's look here. Oh. Ready? I'm going to give you 5 minutes to do said problem. Ladies and gentlemen, it'll be okay. Don't get your feelings hurt. Mr. Mears Gloop want their son Augustus to do his homework every day. Augustus loves to eat candy, so his parents have decided to motivate him to do his homework by giving him candies for each day that he completes his homework. Well, how about that? They're going to give him, cavities. They're going to give him cavities too. So that's just one thing leads to another. I know I ought to give him money. That's the gift that keeps on giving, right? No, that's education. I'm sorry. So Mr. Gloop says that on the first day that Augusta turns in his homework, he'll give him 10 candies. And then on the second day, he promises to give him 20 candies. And then on the third day, he promises to give him 30 candies. And then so on. So write both a recursive and explicit form that shows the number of candies that Augustus earns on any given day with his father's plan. So, ladies and gentlemen, would this be arithmetic or geometric?
Arithmetic.
How you know?
Because it's addition.
Stop the press. It's a what? Constant difference. Constant rate, right? Common difference. constant rate, all that stuff, right? Yeah? A difference. Okay, so what is A1?
10.
How do you know A1's 10?
Because that's the first day he does.
On the first day of Christmas, he gave him 10 candies. Yeah, okay. Now, on second day, it was how much? And then the third day, it was what? Uh-oh. Can't do that. Can't do that. Can't do that. Sorry. Hey, don't make fun of the guy with his teaching tools here. Okay. Did y'all create a table? See, I think that 9 times out of 10, your eyes will pick up on stuff if you just create a table. Things become much simpler in math. I'm a firm believer of that. So, these are going up by how much? So that D equals 10. And then A1, that equals what? Okay. See, if I identify things like that, then when I go to write ones like this, they easy. How they easy? Oh my. You are kidding me. Everything is right there. Now, let's write the recursive. A sub n equals A sub n minus 1. What do we call that right there? We call that a rubber stamp. Why do we call that the rubber stamp? Yeah, that's right. That's going to be there in every one of them recursive equations, right? Mm-hmm. You know I had people miss that. Mm-hmm. Sure did. I mean, they would put like 2 right there. Or 15 or something like that. And I'm just thinking, what did they do? Where were they at during my lessons? Because I ain't never do that, did I? Nope. That means they got popcorn learning. And you got popcorn learning, that's like cheese. Got a lot of holes in it. Right? It's like the Tom and Jerry cheese. Tasty. You're so funny. No, it ain't tasty. Mm-hmm. Now, y'all ready? So, any questions about the first one? Anybody? Anybody? Of y'all young whippersnappers? See, your answer's this one, and your answer's what? Okay, see that? Got it. Okay, now let's go to the next one, because I like this. Use the formula to find how many candies Augustus will have on the 30th day of his plan. Ladies and gentlemen, we're going to take said equation we had over here, and we're going to throw in. You say, well, where's the 30 go, Mr. Palmer? Right here. See that? A sub 30, that means we're finding the 30th term, right? Y'all understand?
Yeah.
And see, that's where that 30 goes. And the 30 goes right here, too. So that's 10 times 29. Mm-hmm. Yep. So, let's see. That's 10 plus 290, right? Anybody want to guess what that equals? A sub 30 is how much? 300. How about that? How did we do? Lovely. Y'all remember doing this on your homework, too? Yeah. Y'all know that homework I gave y'all and said, okay, you can do it for homework. It's going to help you. That table and all that stuff.
Yeah.
I know, because you ought to try doing it. You got to show some more work, too. I got it right. See me after class, and I'll show you my concerns. Thank you. I need you to show work. I am dead serious about what I'm about to show y'all. Augustus looks in the mirror and decides that he is gaining weight. He's afraid that all that... he's afraid... Listen. He is afraid that all that candy would just make it worse. So he tells his parents that it would be okay just to give him 1 candy on the first day, 2 on the second day, and continue doubling the amount as he completes his homework. Mr. Mears-Gloop likes Augustus' plan and agrees to it. Model the amount of candy that Augustus would have each day he reaches his goal with the new plan. First thing first, what you gonna do? Make a table. See, I'm going to make a table. I love tables because if you do a table, guess what you got? You have a visual thing. And Lord help me Jesus, y'all need some visuals. Okay, so on day 1, how many does he get? On day 2? Day 3? Oh, it doubles every day, right? So when it says doubles every day, what does that really mean? That is your constant what? Ratio, that's at R, right? So the R is what? Yeah, it's geometric, right? Because I look at that, that's 1 and that's 2. See, those changes are not what? The same. That's how I would analyze to see if something was arithmetic or geometric. That's what you ought to do with those 6 things on that little breakdown sheet that I gave you homework the other day. So what's A1? I try to do my work as best I can. How do I know? Here's my question. How do I know that this, ladies and gentlemen, hold up. Oh, shoot. I apologize. How do I know that that is in terms of first term? Because look, ladies and gentlemen, the blue is also correct. So how can I tell that the red is in terms of first term? And that the second one, the blue one, is in terms of first term? How can I do it? No, ma'am. How do I know things are in terms of first term? Say it again, Michaela. N minus what? Okay, when you got first term, it's n minus 1. When it's zero term, it's just n, right? Yeah, come on, guys. All right. What is the difference between the blue and the red here?
They already multiplied 1.
Well, sometimes you'll see when your A1 is 1, they'll just do this. Because what's anything times 1, ladies and gentlemen? Itself. So it's kind of redundant, is it not? So please be mindful. That is not in terms of zero term. That is in terms of first term. But the first term is what? 1. Okay. Questions? And if I'd done this right here in terms of, recursive, just for grins and giggles. Then it would look like this. Here's my rubber stamp, right? Now, how do I know just by looking at that is geometric? Anybody want to tell me how I know just by looking at that? Go. No. Multiplication, thank you. What's the difference between recursive arithmetic and recursive geometric? One's in addition and one is what? Yes. Multiplication, son. You need to look at those formulas. You chasing your tail right now, mathematically. You don't know which way's up, dude. You got to get with it. Come on now. It's part of putting it all together. This is a solidifying task, right? Solidifying. All right, so let's go. Let's go here. We got to go down. No, we got to go here. Sorry. I'm going to go there. I'm going to make sure I'm here. And then I'm going to, plan 4. Look right here. Let me grab this and we'll go to that new page. How much would he predict the number of candies that he would have on the 30th day with this new plan? Well, why do you say it would be a lot? I mean, because he thinks that it's really not going to be that much. So where does the 30 go, ladies and gentlemen? Yeah, it replaces the n, right? Yeah, what's that? That's 2 to the what? 29 times 1. So a sub 30, I don't know what that is. Come on, talk to me. Come on. And 12? Yeah, his mom and daddy might want to get a new job because they about to go broke. And he's about to be big the size of a barn, right? He eat that much candy. Lord help him, Jesus. We just can't be doing that now. All right. Any questions on that? Are y'all good? No, seriously, are y'all good? Okay. Who does? Well, if he's like y'all, I'm not calling out any names, but I'm just saying. Write both the recursive explicit show that number candies. Oh, we've already done that, have we not? We done that over here, did we not? We did, right here. Look at that, right here. There you go. You can be the red and the blue or the what? Green, right? Green's recursive and these are the explicit. We've said the difference between the red and blue is what? Yeah, 1 times anything is self. So sometimes when the A1 is 1, they will not show it. So don't not let that get you confused. Okay, so we're going over here. And then we're looking at this. Augustus is generally selfish and somewhat unpopular at school. He's Mr. Palmer. So he decides that he could improve his image by sharing his candy. A smart guy with everyone at school. We call that a weight loss program. Give it to your friends. Now, when he has a pile of 100,000 candies, he generously plans to give away 60% of the candies that are in that pile each day. Although Augustus may be earning more candies for doing his homework, he is only giving away candies from the pile that started with 100,000. He's not that generous, is he? So when he reaches 100,000, then he gives 60% of it away, right? So, excuse me. How many pieces of candy will be left on day 4 and then day 8? All right, have you worked this one? You haven't? Okay, so what I need for you to do, I need you to work, 5, 6, 7, no, 6 and 7, right? There you go. I'm going to stop it, and you can work those. On this problem, he's given away 60% of his candies. How much percent is still there? 40. Ladies and gentlemen, that is your base. Your base is 40, 0.4. Your rate is 0.4. Why? That's right. 40% of it 40% of that will always be there, right? 60% of it's gone. Well, if it's gone, do we really care where it went? No, it went to go get the rest of them people fat, sassy, and happy, right? He got more friends, and they the one that's got eating too much candy, right? That's good. See, he's got a plan. So if it's 60% of it's gone, how much is still there? 40%. So let's look at this. How much did he start with? Okay. Man. Now, is that 100,000? Is that first term or 0 term? Huh? 0 term. That's a sub 0, right? Equals 100,000. Now, I'm going to teach you something. Listen to me, young folks. This is pretty cool right here. We're going to write it in terms of 0 term because they gave us, right? Or I could do what? Did not see them right there, things on my floor. We don't do that. Thank you, sir. Them nasty, in my opinion. Sorry. I don't like them. Okay. If I want to have my first term, what I need to do? I need to take away 60% of it. So what would be left? 40%, which would be how much? 100,000 times point what? Please give me that. 100,000 times 0.4, please. Huh? 40,000? Yeah. Yeah, I'm good. I'm good. I know what you meant. Okay. So I got the first term, did I not? But I could have left it in 0 term, and I'm going to write them so you can see. All right? So the 0 term, in terms of A0, that is 100,000 times 0.4 raised to the n, right? Yeah? Now, I'm going to write it in terms of this, A sub n, in terms of first term. 40,000 times 0.4 raised to the n minus what? N minus 1, right? So really, what is the two big differences here? Can you see them? What's the two big difference between those equations? Go. The n minus 1, thank you, appreciate that. Lovely, wonderful. Let me point that out. There, see, n and n minus 1, that tells you got first term or zero term. Thank you. All right, what else is the biggest difference between those two? What do you mean the number, son? We got numbers coming out the wazoo. Oh, these two numbers, right? What do those numbers right there represent? The 100,000 represents in the beginning, right? In the beginning, how much did we have when we began? Before we started divvying out, right? And then the 40,000 means at the end of the first day, right? Right? Y'all with me? Well, I just told you that, right? So, how much is left on the fourth day? See, I want y'all to do it in both. I want you to do it in both equations. I want you to be able to make sure that you're solid both ways. Do you understand? So, go. I need you to plug it 4 into the red one and then 4 into the blue one and see what you get out. Now, please, when you plug it in, that you're showing all that work to plug it in, right? You with me? Yep. Come on. You can't stare and look at it. You got to pick a pencil up and work it. That's the big difference. Mm-hmm. Okay. Did you get the same thing? What'd you get? Listen, all you got to do is this, guys. Look. 100,000 times 0.4 raised to the fourth day, right? And then you got this. Ace of 4, right? I might just do this, right? Equals. Hold up. Four minus 1, which is what? Now, I'm going to tell you something. You have to do this first. You have to do the power first, and then multiply it by the 100 or the 40, right? You understand? That has to be taking place first. So what do we get right here? Y'all better set back down. Tell me how many you get right here, baby. 2,550? 60. Got 2,560. What about this equation? How many you get out of this? 2,560. All right, because they're equivalent. All right, listen. If you haven't got your Google Classroom code, or if you are struggling or don't know, then today is the help session. This is study hall for math today. I would find my way to my classroom. Do you understand me? You understand? Because next week we got a parent conference and they're going to ask me all this stuff and I'll say, well, I ain't never seen them on Mondays. Get the drift? Bye.